All right, hello, welcome back. Plan today. Um, Going to finish up some of the FRQs that we skipped in the notes. I looked, and they're primarily from 8.2, which I think is good because we'll be quizzing over that sooner. And then we're going to go ahead and put together a little study sheet for chapters 8 and 10. Very complex artifact here, where we maybe write our templates for how to interpret confidence intervals and confidence levels, and then maybe we write down some formulas for confidence intervals for proportions, 8, 2, 10, 1, and confidence intervals for means, 8, 3, 10, 2. So that'll be the approximate plan. I think I'd like to start with our little study sheet. This will be something I'd hang on to, and let's go ahead and consider what are some useful things we've talked about so far. So go ahead to get out your 8.1 notes. I'm not gonna have you watch me write these, but go ahead and copy the templates for interpreting confidence intervals and interpreting confidence levels. Pause it. Go ahead and take a moment to do that. So very exciting. Hopefully you've gone ahead, looked back at your notes, and copied a couple of those real quick. Those those templates. You're going to need these templates. You just have to know them. Confidence intervals. We are C% confident that the interval from lower bound to upper bound captures the true value of the thing we're trying to estimate. Confidence levels. That's more talking about how often does the method work. It's a long-term success rate of the method. C% of all samples this size using this method will yield an interval that captures the true parameter value. We're trying to estimate the parameters. Remember, those parameters are either P or mu. Let's go ahead and look at how we generate those confidence intervals. Confidence interval for proportions looked like, what do we call this? I'll write its name out to the side. This is a one sample Z interval for P. That is P hat plus or minus Z star square root P hat 1 minus P hat over N. So that was our first one. That's on your formula sheet. But it's on your formula sheet kind of indirectly. Make sure you can find your formula sheet. Make sure you know where it is. Confidence interval down here, statistic plus or minus critical value times standard error of statistic. So hopefully you know the statistic is P hat plus or minus Z star standard error of sample statistic P hat 1 minus P hat over N. So recognize that these things are here. The kinds of things we're going to need to create these confidence intervals are hiding on your formula sheet, but maybe not as nicely as you'd like them. So I'll put a little box here around this formula. That's a nice little formula. So we can do one sample Z interval for P. There are certain conditions for that. Those conditions are the same generally for all of these. What else should we have? We should probably put on here the margin of error calculations. That is sample size. So sometimes we'll have to say our margin of error, that is Z star square root P hat 1 minus P hat over N is less than or equal to some specified margin of error. We might have to solve for that. I'll put a little note there. Maybe you don't know what P hat is. I'll put a little reminder. We're going to use P hat equals 0.5 if unknown. It typically will be. You don't usually know the sample proportion before you take the sample. Think about that. You don't usually know the sample proportion before you take the sample. So we've got one sample Z interval for P. We've got margin of error, sample size. I'm going to kind of do something weird here in the middle where I'm going to put our conditions. Put a little box around this, and we'll remind you that those three conditions are random, independent, and normal, which I'll split into two sides, either n p hat and 1 minus p hat are at least 10, or sample size is at least 30, or it has no skew. So conditions, not going away, put those in the middle. The condition that you guys mess up frequently is the normal condition. So we can do that, and down at the bottom, I'll hide the 2 sample z interval for p1 minus p2. 2 sample z interval for p1 minus p2. What's that going to look like? p1 hat minus p2 hat plus minus z star, then big old square root p1 hat 1 minus p1 hat over n1 plus p2 hat 1 minus p2 hat over n2. Put a little box around that. And those are the formulas for confidence intervals for proportions. They're all in your formula sheet. They're all in your notes. Just kind of maybe an organizer that you find useful. These are the big ideas of this unit. It's what's going to help you do the review, which is going to be your assignment for today. Over on the other side, confidence intervals for means. We'll have our 1 sample t interval for for mu. Almost put x bar there. That's going to be x bar plus minus t star. Remember, n minus 1 degrees of freedom, s x over radical n. It's on your formula sheet. Should be able to put that together. Margin of error. Can't do it with t star intervals. So our margin of error, that is our sample size calculation, can only actually come from the 1 sample z interval. So I'm going to put this kind of in blue. The rare case is x bar plus minus z star sigma over radical n. This is very rare, but it does lead to the only way we could do a confidence interval, a sample size calculation here, which would be z star sigma over radical n is less than or equal to some specified margin of error. Okay, and last thing we're going to need on here down at the bottom is our 2 sample t interval for p1 minus p2. Not for p1 minus p2, but rather for mu1 minus mu2. Difference in means this time. That's going to be x bar 1 minus x bar 2 plus minus t star square root s1 squared over n1 plus s2 squared over n2. Put a little box around that. And that is a pretty good looking study sheet for chapters 8 and 10 on confidence intervals. It's kind of rough. It's not everything, but those are the major formulas. Those are the major ideas from chapters 8 and 10. Obviously, there's more to it. There's lots of detail, a lot more you could add on to this. I've left some space here. Seems like good space to put stuff you forget. Okay, let's go ahead and look in the notes. Go back, do a couple of 8-2 confidence intervals. We'll get those done, and we'll call it a day. So let's pause for a moment, switch over. As an aside, looking through the notes, trying to get to the FRQs that we skipped, and I noticed this very nice page. tell you to put it on a note card. It's what we've just done. It's all the specific confidence intervals and the formulas we will use when. Some of you might consider putting some of those use whens out there. Those are the conditions. Those are the things that show up in the middle. But really, I've taken what's particularly relevant from this, and that's how I've created this sheet here. So hopefully that's of use. Let's look at a couple 8.2 FRQs, starting with 2017 number 2. Great question here, talking about soda thieves. So let's read through the question together. I'll mark it up as I find necessary, and then I'll probably pause and let you do the bulk of the work. Manager of a local fast food restaurant is concerned about customers who ask for a water cup, but then fill it with soft drink. Not a problem in the time of COVID. The restaurants are closed. The manager select a random sample of 80 customers. Okay, I'm gonna circle 80, or maybe out to the side, I will write n equals 80 customers. Told it was a random sample. That's nice. Found that 23 of those customers filled the cup with soft drink. So we'll call X is 23. X would be the number of successes, the number of people that said yes here. NP. Constructed and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with soft drink from the beverage fountain. And we are just going to steal that phrasing verbatim. Just steal it. Don't try and come up with a new way to define the thing that they told you to look for. Use their language, because they're asking you to do the work. Okay, so let's do part A. I'm gonna at least set it up for you. You're gonna go back and do the work. So we're gonna go first, obviously start with a state step, and the first thing we're gonna do is what I told you. We're gonna just copy the thing it told us to find. P is the proportion of all customers who, having asked for a water cup, will fill the cup with soft drink. Great. We're going to construct a 95% confidence interval for P. Then plan step. We go ahead and we name the procedure. So name of the procedure. Sheet. One sample. How many samples we take? We took a 1 sample. It's a interval for proportions, so it's going to be a Z interval for P. And then we need to check the conditions. We were told that we took a random sample. We told we took a random sample. We must assume independence. How do we assume independence here? We assume independent by saying there are at least 10N, that is 800 customers. And then the last thing we need to consider is normality. How do we establish normality here? We need NP hat and N1 minus P hat to be at least 10. Well, how many people, NP hat, that's the number of successes we observed. That's 23. N1 minus P hat, that's the people that didn't steal. That's the 57. Those are both at least 10. So our 3 conditions are met. We can assume the sample statistic is distributed approximately normally, and that lets us then create a confidence interval using a Z star, a normal critical value. You go ahead and do it. Get your calculators out. This is the easy part. Somehow I've done all the work for you here. Go ahead and do. No. Ooh. Well, as I'm fumbling for papers, you get your calculator out and do this thing. What are we going to do here? We're going to do stat. We're going to go over to tests. We're going to do a 1 prop Z int. That is option A. We had 23 successes out of 83 in our sample. We're making a 95% confidence interval. Boom. 0.18832. to 0.38668. Great. So we think it's between, I don't know, a little less than 19%, like 19 and 39%, somewhere in there. What's in the middle? I don't know. What's 23 out of 80? 28.75% in the middle. Fantastic. Okay, so it's somewhere around 29% plus or minus 10-ish. It's pretty wide. It's not a very big sample size. 10% margin of error, that's pretty big. Go ahead and conclude. Do that over here. We are 95% confident that this interval right over here captures, write it all down. Okay, the true value, the proportion of those who, having asked for a water cup, will then fill the cup with soft drink. Okay, make sure you write it all down. Make sure you're using the template. I've run out of room because I want to fit part B in here. Part B talks about costing the restaurant 25 cents. Every thief costs the restaurant 25 cents. Suppose in June, 3,000 customers asked for a cup. Use the confidence interval to give an estimate for the cost to the restaurant for the customers who ask for a water cup but fill it with soft drink. Well, what are we going to do? We're going to take our interval. We're going to multiply it by 3,000 to get the confidence interval for the number of people. When we multiply each side of that interval by 3,000 times 0.18832, we get lower bound is approximately 564.96 people. Upper bound, 0.38668 times 3,000 is 1,160.04. Fantastic. So now we have a confidence interval for the number of people that we think are going to steal. Well, if we know the number of people and we multiply it by 25 cents, that's going to give us the confidence interval for the loss due to the thefts. So we multiply each of those bounds by 25 cents. I'll multiply the upper bound since I've already got it up on the screen, and that gives us an upper bound of $290.01. A lower bound, 564.96 times 0.25 gives me a lower bound of $141.24. So we've now generated a confidence interval for the amount lost by this restaurant, starting from a confidence interval for the proportion of people that are going to steal. We went from a proportion of people. We took that, multiplied by the number of people to get the confidence over the number of people, and knowing the loss per person that steals, we can come up with a confidence over the total loss. Fantastic. So one confidence interval down. Let's flip around. I think we have one other one that I'd like to do. And this is 2015, number 2, right here, a question heavy on the old margin of errors. This is all we'll do today, then we'll be done. All right, so 2015, number 2, take a moment to read through it. One of those ideas that I told you was never going to leave is this idea of this inverse square root relationship with the margin of error. Let's take a look and see what the heck am I even talking about. To increase business, owner of a restaurant's running a promotion which the customer's bill can be randomly selected to receive a discount. Great. Bill's printed, cash register determines whether the customer will receive a discount. Program was written to generate a discount with probability of 0.2. However, the owner is concerned the program is a mistake and the program is not generating the intended long-run proportion of 0.2. Okay. Owner selected a random sample of bills that found only 15% of them received discounts. A confidence interval proportion P was generated, and he made this interval 15 plus or minus 6. Okay, all conditions for instance were met. Great. A second random sample of bills was taken that was 4 times the size of the original sample. Okay, in the second sample, 15% of bills received the discount. So again, that's a p hat equals 0.15. Determine the value of the margin of error based on the second sample of bills that would be used to compute the interval for p with the same confidence level as the original interval. Well, what do we know? Let's take a look at part B. The original margin of error was 0.06, which is, something like square root 0.15, 0.85 over n. So that was the original margin of error. But now we're telling you the new margin of error it goes along with a sample size that's 4 times larger. Okay, so now the new margin of error is going to kind of look the same. It's still going to be 0.15, still going to be 0.85, but now in the denominator here it's 4n. Well, what can I do? I can pull that 4 out because square root of 4 is 2, and so this becomes 1/2 square root 0.15, 0.85 over n. Well, that's just the original margin of error. So that's 1/2 me original. Half of the original margin of error is 0.03. Great. So that new margin of error will be margin of error new is 0.03. Great. Based on the margin of error that was obtained in the second sample, what do you conclude about whether the program is working as intended? Justify your answer. Well, now the interval is now 0.15 plus or minus 0.03, which is 0.12 to 0.18. What's not in that interval? Since 0.20 is not contained in the interval, it isn't a plausible value. I suspect the machine isn't dispensing discounts as intended. Fantastic. So one of these things that we're going to have to do is make intervals to say, is this claimed value, I'll write this out the side, is the claimed value in the interval? Because remember, intervals give you ranges of plausible values. If it isn't in the interval, it's not plausible according to the method. So we can use that to make decisions about a claim. Doesn't seem to be true. So that is, I think, where I'll stop for today. You've got another example here about Mike and Lori. Very similar to the soda example we've just done. I'll leave that as it is, and we'll call it a day. Next time, we'll probably start doing some FRQ practice. Your assignment, well, it is listed on Schoology, and for my split block people, it's to start the chapter reviews. So we'll see you around.